Hello everyone. Long back we have discussed about this particular bike sharing dataset. I hope by now you guys might have already tried this assignment. If you haven't tried, then please try it out and then jump into this particular video. Now let's check the solution for this. So before moving on to the solution, let me just tell you about the features that we have. Let's see what are all the features that are available with us. The first feature that we have is the instant, which is just the record index. And then we are having date day, on what date the user might have taken the bike on rent. And then we have the season. And in this, we are having four values: 1, 2, 3, and 4. First one is spring season, and then summer, fall, and winter. And then we are having year. In year, we are having two values, that is 0 and 1, followed by we are having month. In month, we are having values from 1 to 12, corresponding to January, February till December. And then in hour, we are having 0 to 23. And then in holiday, we have whether it is a like holiday or not, it will be represented with 0 or 1. And then in weekday, we'll be having values from 0 to 6. And then similarly, working day or not. And in weather situation, we are having four values: 1, 2, 3, and 4. Each is corresponding to specific weather situation. Like if it is 1, it means that the sky is clear and it has very few clouds. And if it is 2, then we can think of it as a slightly cloudy. And then when it is 3, it is some snow is there. When it is 4, then there is some heavy rainfall. And then we have temperature, a temp, which is feels like temperature. And then we have humidity, and then wind speed. And finally, we have the number of casual users, and then number of registered users, and also count. So these are all the features that are available. In this, the main output feature that we have is the count. This is what we need to predict given the input features. So first of all, if you remember the data pre-processing techniques that I have discussed, the first thing that we need to do whenever we have such data set is to observe which all features are important and which are not important. Like basically here we can understand by seeing these features, right? We can tell that whether year is affecting the count or not, or whether instant is affecting the count or not, because we have some knowledge regarding this. In real world, we'll see such cases, right? Some might take bike on rent. So at what time the count might be higher and what time the count might be lower, that if you think, we'll get to know. Like let's say if temperature is very high, then there is very less chance that people will be taking bike on rent. And similarly, weather situation is very bad, then there is very less chance that people will take bike on rent. So like that, we can understand what feature might be important and what feature might not be important. With this basic information, we can clearly tell that some are not at all important. Such not at all important features we can exclude. So such features can be like instant, which is just the row index. So there is no need of this particular feature in order to predict the output, that is count. And similarly, if you observe date, from date, what we can do, we can extract out some important features like month and year. So these are the main important features that are available in date, but we have month and year columns separately. So there is no point in using date as well. And then if you check the year, if there are multiple years, like some 5 or 10 years, then we can observe like in some year like 2020, the rentals will be very less. In some other year, it can be very high. So at that point in time, it might matter, but these are some normal years like 2011 and 2012. So there is no point in using year as well. And do you think any other features do we need to remove? Just think, mostly like these are the features that we can directly remove instead of keeping them with us. We'll be removing this instant, and then we'll be removing this date and then year. And then are there any missing values or not, we need to observe. And if there are any missing values, we need to follow some strategy to fill out those. And similarly, we need to do some encoding, and also we need to do some scaling if needed. And finally, after doing all these things, we need to build our linear regression model. Okay, so this is the thing that you guys need to do. And if you haven't done, please try it out on your own, then look into this particular video, then you will understand how we can code for this as well. So first of all, I'm importing all the required libraries, and then our data is present in this particular r.csv file. So I'm loading that particular data. And then if you check the data.head, you'll be getting the top 5 rows. So as I said, the first row is instant, which is not at all important, and date day. And then here, these three are not at all important, but we are having them as our features. So let's see how to remove and all. Like we'll be removing in the later stages, but now let's continue. So data.info will be giving us what are the total number of rows that are available with us, and what is the data type of each and every column that we have or feature that we have. So that information we can check, and also it will give us the count of number of non-null values. By observing this as well, we can clearly know what is the number of missing values. But instead of this, if we use data.isNull.sum, it will be better because it will be giving us the exact number of missing values in each of these columns. By seeing this, we can clearly understand that there are no missing values, so there is no point for handling this particular missing values. Skip that pre-processing step, and these are the columns that are available with us. Okay, and if you wanted to check what are the number of unique values available in each of the columns, simply you can use that column dot unique. So as we are having multiple columns, we can apply some lambda function on the data that we have. So it will take each column, and on that it will apply this unique function, which will be giving us the total number of unique values present in each of the columns. So instant is a row index, that's why these many number of different values are available. Whereas date day, we know that this call collected for 731 days, that is shown over here. And similarly in season, we know that there are 4 distinct values, and then in year we are having 12 distinct values. Month we have 12, and hour we have 24. All these we already know. Basically, in some cases it will be higher. That is because these will be some continuous values. Weather situation, we already know that there are 4 distinct values, and weekday too. So all these things which we already know the number of unique values, those are discrete features, and remaining which we don't know basically are the continuous features, because here it is 50, but if you're using some diverse data, then it can go even higher. Okay, this is about our data. Now let's drop the features that are not at all important. The first feature is the instant, and then date day, and then the year. So these we wanted to remove. In order to remove them, we can index them and then remove. So first, this is indexed with 0, that is instant, and then date day is indexed as 1, and then year is indexed as 3. So we are dropping out all these 3 columns, and as we wanted to drop columns, we need to keep access equal to 1. So now in data, we will not be having those 3 columns, that is instant and date day and then year. So if you observe, there is no instant, date, day, and year, and these are the columns that are available with us. Okay. So now let's take out the categorical features that we have. So we know that these are all continuous features. Okay. And similarly, all the features apart from instant, date, day, and year about this are categorical features. Okay. I have listed down all the categorical features that we have, that is season, month, hour, holiday, weekday, working day, and weather situation. And now let's try to analyze our data. And why are we doing this analysis? Because it is really important in order to make some good model. So how our data is, we need to understand it in a better way. So in order to understand that, you need to have some really good questions on the data that we are having. Okay. So one such good question can be like, how many rentals are happening according to the hour and according to the weekday. Like let's say in each weekday at particular hour, what is the count that we have. If you wanted to observe this, in order to do that, we can simply use some plotting technique. That is, we can use something like point plot. In this point plot, on x-axis we are taking hour, and on y-axis we are taking count. Basically, if you are just taking this x and y without hue, what it will do, on each hour, what is the count of bike rentals that are happening, that information it will be giving us. As we are giving hue to be weekday, it will be separating out all of this based on weekday. Okay, let's see the graph. So here, if you observe the graph, we are having different colored lines. Each colored line is corresponding to some separate weekday, and all these points are representing the corresponding count on the hour. Okay, so at 0th hour, this is the count of rentals that happen, and at 8th hour, this is the count of rentals that happen on like weekday. You can think of it as Sunday, Monday, Tuesday, Wednesday, like that. Okay, this is the data that we are having. By seeing this data, we can clearly observe some real world behavior. That is basically, if you observe, there are 5 lines which are showing same kind of structure, whereas there are 2 other lines which are showing same structure. So can you guys guess out what are these 2 days? Guess it out and comment on the comment section before I reveal the answer. Basically, these 2 lines will be our weekends, that is Saturday and Sunday, whereas these 5 will be our Monday to Friday. So on working days, the way people take bike on rent will be slightly different, whereas on non-working days it will be slightly different. So that pattern we can clearly observe over here. That means that as it is following some real world behavior, we can clearly understand by seeing this graph itself that it got collected from real world. Okay, so it is not some randomly generated data. It got really collected from some shop. Okay, so that's what we can understand from this. Basically, if we observe in these 5 days, what is happening in at this particular point in time, no guys are taking bike on rent, but after 5, slowly it is increasing, and at 8 we are seeing some peak, and after that it is slowly reduced, and it is maintaining some stable count, and finally in the evenings it got increased. That is because so many people might have gone to office in this particular region. That's why the count is slightly lesser. But in the morning and in the evening, people will not be in offices, so there is a higher chance that they might take bike on rent. Okay, so this is about this particular bike rental system. Whereas in case of weekends, it is like this. In the nights, maybe due to some reason, they might be going on a trip or something. They might be taking on rent, so this count is slightly higher. And basically, if they wanted to start in the mornings, then definitely they'll not wake up early. As it is a weekend, so many might be sleeping till some 8 or 9. So that's why the count is gradually increasing. We This is not the highest peak, but from 10 onwards, this is maintaining some very good number. Okay, it is slowly increasing, and similarly in the evening it is decreasing. So this behavior is clearly kind of a real world behavior that we can clearly understand by seeing this graph. And also we got so much information by just seeing this graph, right? So in each weekday, what is the count with respect to R, we are able to understand from this. And also if you see the data in this, there are 3 separate columns, that is casual, registered and count. So let's try to see how it is affecting the casual users and how it is affecting the registered users. Okay, so this graph we have seen with respect to the count. Now with respect to casual and registered also, let's see how the graph is like looking like. So first let's take casual users. So if you observe the casual users, the corresponding graph is looking like this. That is, these 2 lines, that is pink and blue, are corresponding to weekends, right? That is Saturday and Sunday. In Saturday and Sunday, the graph is almost the same, or it is slightly higher over here. So it is maintained in the same way. But in the weekdays, the number of casual users are very less. On weekends, the number of casual users are high, but on weekdays, it is very less. That we can clearly observe from this. So basically, from this, we can understand that there are so many registered users who are who are taking bike on rent on daily basis. On working days, they might be taking bike on rent and going somewhere. So that's why this particular graph pattern we are not able to check in this. But if you observe the registered data, then it might look similar to this graph. So let's check the registered graph with respect to hour and weekday. We are using the registered, and this is very similar to the graph that we have seen. Okay, so basically, if we can minus out everything from this particular graph, then we'll be getting this. Okay, so this is about our count with respect to the hour and weekday. Okay, so our count, actual count, and then casual count, and then register count we have checked. Okay, before moving on to the other graph, do you guys think that is this particular encoding correct or not? Basically, all the weekdays got encoded, right? So this we understood that it is Sunday and it got encoded with 0, and Monday got encoded with 1, and Tuesday got encoded with 2, like that. Each of the days of the week got encoded like this. But do you guys think that is it a correct encoding? Basically, you might have some data set, but that data set might not be encoded properly. Most of the guys, what they'll do, you might be using those features directly and you are passing to the linear regression model, then you might not be getting good results. Okay. That is because whatever encoding that you're seeing might not be correct always. So we need to ensure that the encoding that you're seeing is maintained correctly. So here if you observe, weekday is following this encoding that is 0, 1 to 6, but this is not exactly correct, right? Because if you observe, these two Saturday and Sunday are somewhat looking equal, whereas remaining 5 days are looking similar, but it is not following any such pattern like first there's a Sunday and then followed by Monday and then followed by Tuesday, like that. It is not following any order. If you observe over here, these two are similar and these five are similar. So that's why this is not a best encoding to follow such behavior. So what encoding can we use? We can use some other encoding technique like one hot encoding, which might work better. In one hot encoding, our idea is to give equal importance for each and every weekday equally and let the model decide which weekday is more important and which weekday is less important. Like that, we need to analyze our encodings as well, whether it is correct or wrong. So we understood that this weekday is not encoded properly. And then let's see with respect to the weather situation. And if you observe, in weather situation, whenever it is 1, the count is always higher. Most of the time it is higher over the time. And similarly, when it is 2, it is slightly lower than this one, but greater than the others. And here it is lower than this orange line, but higher than this particular fourth color always. And similarly, at last we have this. So if you guys remembered, 1 means that the sky is clear, 2 means that slightly cloudy, and 3 means that slight snow is there, and 4 means that it is raining, right? So, like basically, whenever it is raining, no one will take bike on rent. That behavior we can clearly observe from this graph, where there are only very few points that are 2 points. In other cases, it is following some clear difference. That is because obviously, when the sky is clear, and the weather is good, then most of the people might be taking bike on rent. But if it is slightly cloudy, then they might feel that it might be raining in future and they'll not take bike on rent. That's why we can clearly see the difference in the graph. By this we can understand that this encoding is correct. And then let's see with respect to the season as well. So here also most of the time we are observing some pattern, green followed by orange and then followed by red and then followed by blue. But if you observe over here, first we are having blue, that is the least one, and then followed by orange, that is this one, and then followed by green, that is this one, and then followed by red. So this encoding is not correct actually. Either you can encode this green to 1, this orange to 2, this red to 3, and this blue to 4, or you can do it in reverse, like this one 1, red 1 2, and orange 3, and green 4. But this encoding is jumbled, that they might have used some encoding like label encoding. In label encoding, what happens, we'll randomly assign some number, right? So that is what they are doing over here. So that's why this encoding is also not correct. So instead of label encoding, we might use some ordinal encoding, like we can assign 1 to this, 2 to this, 3 to this, 4 to this. Okay, now let's move on. And now we are observing the graph with respect to the month, and on y-axis we are taking count. Okay, and here if you observe, our month is 1 means January, 2 means February, like that, going till 12. Are you guys observing any specific pattern? So here, if it is continuously increasing, then this order is correct, but it is not continuously increasing. What we can do, we can simply apply one hot encoding and let the model decide which month is more important and which month is less important. And similarly, with respect to the weekday as well, with respect to weekday, we have observed here as well, like how it is affecting the count with respect to hour. But here also, if we observe, almost all are corresponding to equal count. So that's why we can apply one hot encoding over here as well. And similarly, if you wanted to remove any other extra columns apart from the columns that we have discussed, then simply you can use this data dot correlation and we can remove some of the features. So here if you observe clearly, like basically here 1 means that they are highly correlated, or -1 also means that they are highly correlated. But this graph is not going till -1. So 1 is shown with lighter color, where near to 0 or less than 0 is shown with very dark colors. So basically if it is 1, when we'll have 1 in the diagonal, we might be having 1, and whenever there is very light color, that means that they are highly correlated. By observing this graph, I can understand that month and season are highly correlated, and temperature and air temperature are highly correlated. So between these two, we can only use one feature instead of going with two. And similarly, between these two also, we can go with one feature instead of going with two. Okay, that is what we can do. Like we have discussed, we have thought of applying one hot encoding, right? So let's take our categorical features. And in this, I am excluding the weather situation, because in case of weather situation, the encoding is exactly matching with the data that we have. So that's why we are excluding the weather situation. And in remaining all cases, we can use one hot encoding. Instead of using 2-3 encodings, let's simply use one hot encoding in all the cases. So in order to do one hot encoding, we can simply use this pd.getDummies, and then we are passing our data. And in columns, we are passing all our categorical columns, and we are giving drop first equal to true. Now we are left with all these columns. There are 4 different seasons, and for 4 different seasons, if you are simply applying one hot encoding, then it will create 4 different features for season. But as we are mentioning drop first equal to true, it will drop one of the columns, and we are left with 3 columns for season. And similarly for month, we'll be left with 11 columns, and for weekday, we'll be left with 6 columns. Okay, this is like after applying one hot encoding, we are left with this many number of columns, and this is the data that we have. Now let's apply some scaling. So we are using min-max scaler over here. What will min-max scaler do? Min-max scaler will make the scale to 0 to 1. Basically, all these are one hot encoded, right? Here the values will be in between 0 and 1 only. That's why we are only considering these features, that is temperature, humidity, wind speed, all these features in order to make scaling. So we are selecting from 1 to 5. First we are fitting, that means we are finding min and max, and then we are applying the formula, that is x minus min by max minus min, for applying the min max scalar. And after this, in y, we'll be placing our output column, and we'll be removing that column. Along with that column, if you carefully observe, we are removing extra 2 other columns. Those are casual and registered. And why are we doing this? That is because if you carefully observe, these casual and registered, if we just sum up, we'll be getting the answer. Okay, so that means that basically these are part of the output. So you should not include such features which are part of the output itself. So we need to predict this count, or sometimes they might ask you to predict this casual, and sometimes they might ask you to predict the registered. These are not the input features. These are corresponding to output features. That's why we should not be including such features. So we are removing both casual and registered as well. So here we are selecting 5, 6, and 7, which are corresponding to this casual, registered, and the count. And we are passing x equal to 1, which means that we are removing the columns. Okay. And y, we are placing this count, and from the input, we are removing all these columns. Okay. Now we are left with all the input features, and in y, we are left with the output feature, that is count. And finally, what we are doing trained and split. That is, we are dividing the data into 2 parts. One is the training data, and the other one is testing data. And here we are keeping our testing size to be 0.2. That means 20% of the points will be in the testing data set, whereas remaining 80% will be in the training data set. So we are fitting our training data, and then we are predicting on our testing data. And the amount of error that we have on the testing data is this much. So by seeing just the error, we'll not get very good idea. So let's see the score. And these are all the coefficients that got adjusted while applying linear regression. If you check the auto score, for training data, the auto score is 0.41. and for the testing data it is 0.38. That means that our model is underfitting, because on training data itself the score is not really good. By seeing this, we can clearly say that our model is underfitting. Whenever in case of linear regression our model is underfitting, what we can do, we can go on to polynomial regression. In polynomial regression, we'll include some higher degree features, that is degree 2 features. So first we are creating degree 2 features, and then we are passing our data. So in X-train poly, we'll be having our degree 2 and degree 1 features, and then we are passing our Y-train. Like basically here we are passing X-test in order to get higher degree features for testing data as well. Because when we have higher degree features for testing data, then only we can pass all of them to the like model that we have, because model expects those many number of features. That's why we are doing this. And then finally we are predicting on the testing and training data. Now if you observe the R2 score, for training the R2 score is 0.83, and for testing it is 0.80. So now it is better when compared to the previous model that we have, right? So previously we used to have a score of 0.41, 0.3, but after applying this polynomial regression, we are getting a score of 0.83 and 0.80. In case of regression, the score is pretty good. Okay, so I hope this video is clear for everyone and you're able to understand the way we did the data pre-processing and the way we build the model. And once we see the situation that it is underfitting, then what steps we have followed. All these things I hope you guys have clearly understood. That's it for this video. Thank you everyone. Bye bye.